Hi everyone, welcome to this channel. In this video, we are going to discuss financial mathematics. Okay, before I go to grade 12 topics, let's look at these formulas that you studied in the junior grades. First one is a simple interest formula. That is, when you deposit a money in the bank and the bank is offering simple interest, after sometimes, okay, a particular number of period, how much money will be there in your account. So the bank can offer simple interest. So you are using this formula, first formula, where P is the initial amount and A is the final amount, where I is the interest rate and N is number of period. And I we are calculating R divided by 100. This formula we are using to calculate I. Is it clear? Now we move to compound interest formula. That is the second formula, compound interest formula. That is, bank is offering compound interest. So this compound interest can come monthly, quarterly, half yearly, or per annually also. So we are using this formula, the exponential one, that is A is equal to P times 1 plus I all to the power n. So these two formulas, we can see we are using this formula where our money is increasing. You understand, after a particular number of times. Now coming to depreciation, which means if you bought a car or bought a house after a particular, if you want to sell that one, so you won't get the money that you used to buy that time. So their money is decreasing. So here we are using, again we can see that straight line depreciation. Here same like a simple interest formula where instead of plus they are using minus. Then the reducing balance formula is also there, that is compound interest formula where instead of plus we are using a minus. Okay, especially the reducing balance depreciation is very important when it comes to calculating book value of a car that after 5 years, 10 years. So we are using or finding the scrap value of a car. So we are using this formula, reducing balance. When it comes to the interest rate, we have two types of interest rates are there, that is effective one and a nominal one. Effective one means it is applied once in a year, that is effective one per annum, once in a year. But nominal interest rate, it is applied once in a year, but it can be compounded monthly, quarterly, half yearly, that is nominal one. So in a year, I mean the first year both are same. That is why we are using this formula for the conversion. That is 1 plus I effective 1 is equal to 1 plus I nominal 1 over m to the power m. This formula is applicable for 1 year, which means if it is quarterly, this m become 4. I divided by 4 to the power 4. If it is monthly, then 12 you have to use it in the place of m. If it is semi-annually, you have to use 2 there. So I will write it here. If it is monthly, then I divided by 12. Then corresponding changes you have to make it for n also. N times 12 number of period. Okay, then if it is quarterly, I divided by 4. So how many quarter in a year? That is 4 quarters are there. Each quarter means 3 months. So corresponding changes for n is n times 4 you have to make it. Then if it is semi-annually, I divided by 2, which means n times 2. You have to change it in the formula. Okay, then weekly is there, but hardly they ask about a weekly. If it is weekly, then I divided by 52. That is n times 52. The number that you are dividing with the I, you have to multiply with the n. Then daily also can come, which means I divided by 365 or n multiplied by 365. This is how you have to make corresponding changes. So these all are talking about nominal interest rate. Okay, so that m value you have to change it accordingly. Is it clear? Let us do 1 or 2 questions based on this conversion. Okay, look at this question. Convert a nominal interest rate 10,1% per annum compounded monthly to an effective interest rate. This conversion question is very important. Okay, here what is given? The nominal one is given because this word will help you to identify monthly, quarterly, half yearly. If you see this word means it is nominal one. Okay, so you have to find the effective one. So let me use the formula. I'm going to substitute here, that is 1 plus effective interest rate that you have to calculate, then 1 plus nominal, that is interest rate I is equal to 10 comma 1 divided by 100, that is 0,101 divided by m here, because they are talking about monthly, means divided by 12, then all to the power 12. Then the right hand side, when you do it in the calculator, you will get 1,1058,09149. Don't round it off before you get the final answer. 1 plus IE. So now interest rate IE is equal to, effective interest is equal to, send to one other side, it's going to subtract, then it's going to be 0,1058,09149, you will get it. Therefore the rate is equal to, because I is R over 100, isn't it? Rate is equal to, multiply this one with 100. So the answer is 10,58%. This is the answer. Effective one is bigger than nominal interest rate. Clear? Now let us do one more question where effective interest rate is given. Find nominal interest rate. Okay, look at this question. Convert an effective interest rate of 9,1% per annum to a nominal interest rate compounded quarterly. So the one that is given is effective one. The one that you have to calculate is nominal one. Let me write the formula. The formula is 1 plus IE is equal to 1 plus I and nominal 1 divided by m to the power m. So 1 plus I is what? 9,1%. When you change it into decimal, so divide by 100, that is 0,091 is equal to 1 plus nominal interest rate divided by m. We can get it from the question. Quarterly means what is the number? 4 is the number. So the power also 4. Now simplify, because the one that we are looking for is on the right hand side, right? So 1 by 1. So the left hand side, 1 plus 0,091 is 1,091. Isn't it? Then send this 4 to the other side is going to be, because here 4 is the power, so this is going to be fourth root of that number is equal to 1 plus in divided by 4. You will get it. Then fourth root of this one you will get it like this: 1 comma 022012453. You have to write everything. Don't round it off here. Is equal to 1 plus in divided by 4. Now I'm sending this one other side, that is going to be subtracted. That is in divided by 4. You will get it. So what is the interest rate? Nominal one divided by 4 is going to be 0,022012453 when after the subtraction with the 1. Now interest rate is going to be 4. You have to send the other side is going to multiply this number. So it's going to be 0,088049812. You will get it. Therefore, the rate is going to be, because I is R divided by 100. So send 100 other side. 100 is going to multiply this side. So it's going to be 8,8 percentage. You get it. This is how we are finding. This is the interest rate, nominal interest rate compounded quarterly. So this is how we are converting effective to nominal and nominal to effective. The reason why I did this question, because this question is very important. That is why. Okay, now we can move to grade 12 topics, that is annuities. Okay, In this is annuities. Annuities means an equal payment is made. That is annuity. In a regular interval, we are paying an equal amount. It can be monthly, quarterly, semi-annually. We are paying an equal amount. So in every interval, you are paying an equal amount. That is annuities. There are two situations these annuities are there. First one is a future value annuities. Future value annuities. Future values annuities, this we are using especially when it comes to savings. A situation where the question is talking about savings or sinking fund. Both are same. Sinking fund. Sinking fund means you want to raise a particular amount in future that you will be using for some other purpose. Okay, so that is a sinking fund. Savings, both are the same things. Okay, so the future value annuities. Okay, future value annuities. I will show you how to derive this formula, though the derivation is not important. Okay, let me use a timeline to derive this formula. Let me draw the timeline. So always timeline, remember this thing, it must start with the T0, then T1, then T2, T3, etc. Then Tn minus 2, Tn minus 1, then the last period, that is Tn. And here I am just using monthly. Every month I am saving a particular amount of money. Okay, so that equal amount at the end of first month, that is here, I am putting that one X. X, we are using the letter X to represent the equal payment or installment. Okay, so here savings, so I have to save every end of a month X value. Okay, so the end of first month X, then here X, here also X is going to continue up to here. It's clear. Now I'm going to calculate the future value. FV is equal to, see, look at the last equal payment, that is this one is there in the account without any interest. Then the next one has to go with the 1 month interest, that is plus X times 1 plus I. Then third last one must go with the how many months, first month and second month, that is X times 1 plus I, 2 months interest is going to go like that. So altogether how many terms are there? N terms are there. Okay, n terms are there. That is, when it comes to this one, it has to go n minus 1 months. It has to go like that. So altogether n terms are there. Now look at the right hand side. This is forming what? A geometric pattern, isn't it? A geometric series. So future value is going to be, when you add the right hand side, I am using the formula. Okay, when it comes to the addition, I am using the formula. Since this one is a geometric series, I can use this formula, r to the power n minus 1 divided by r minus 1. Because here a is the first term, that is x. Then r is first term, second term divided by first term, that is going to be 1 plus I. So let me substitute, that is future value is equal to a is x. Inside, in the place of r, let me write 1 plus I to the power n minus 1 divided by 1 plus I minus 1. So the denominator, when you open the bracket, 1 going to be cancelled. That is future value, the money that the accumulated money at the end of this time, you will get x 1 plus I to the power n minus 1 divided by I. So this formula you need to know. So we are using this formula to calculate what? The future value annuity when it comes to an equal payment. Is it clear? Okay, now look at this question. That is example. Okay, example number 1. that is Selby decided today that he will save. So we can see that here it is about the savings. Okay, he saved 15,000. He saved 15,000 per quarter over the next 4 years. So every quarter means every 3 months, he is savings 15,000. He will make the first deposit into a savings account in 3 months' time. That is the first quarter. The end of first quarter, he made that first savings. He will make it, and he will make the last deposit at the end of 4 years from now. Okay. Now 1.1. How much will Selby have at the end of 4 years if the interest is earned at 8.8 percentage per annum compounded quarterly? So here compounded quarterly. So you have to find how much money will be there in his account at the end of 4 years, isn't it? So this question is about savings. So you have to calculate the money, that is the future value. So you have to use the formula FV is equal to x times 1 plus I to the power n minus 1 divided by I. This is the formula that we are using. So what will be the future value? That is the question. So x is the equal payment. What is the equal payment here? 15,000, right? Okay. Then 1 plus, what is I? Here the interest rate is given 8.8 percentage. That is, so the I is going to be divided by 100. That is 0.088. Since this one is quarterly, so divided by 4. Then all to the power n, 4 years means how many quarter? 4 times 4. So I divided by 4 and n multiplied by 4. I showed that one in the beginning of this video. Then minus 1 over, again I is 0.088 divided by 4. So here the main thing is how to use the calculator. So here when you type it in the calculator, this bracket and everything, you have to put it correctly. Otherwise, you won't get the correct answer. Okay, and the rounding off, you have to do it at the end. So here straight away type it in the calculator. Don't forget the brackets. So you will get, if your calculation is correct, you will get the answer around 283,972 907, 2779 2779, you get it. When you rounded off 2 decimal places, it's going to be around 283,972,28. So this is how we are using. So I just showed you one example based on future value. Okay, now coming to the present value annuities, we are using this formula when it comes to loan. Okay, for example, you are applying for a loan and the loan is granted. So PV is the loan amount, okay, and you have to pay with the interest this back to the bank, the loan with the interest, okay. So equate loan money with the interest for n number of times to equal payment with the interest for n number of times. So the right hand side is same like a future value, that is x plus x times 1 plus I plus x times 1 plus I to the power 2 is going to go like that. How many times? N times. So the equal payment can be a monthly, quarterly, half yearly, it's like that. So this x is this one without interest. Then next x is this one with the 1 month interest, that is y to the power 1. Then this one is this x with how many months? 2 months interest is going to go how many times? N times. So the present value, the loan amount 1 plus I to the power n. The right hand side you can use, because that one is a geometric series, you can use the formula. The formula I will write up there, a r to the power n minus 1 divided by r minus 1, where a is x, r is 1 plus I. That is, if you use that formula, it's going to be a 1 plus I to the power n minus 1 divided by I. You get it when you simplify. Is it clear? Therefore, present value is equal to, you have to divide both sides with 1 plus I to the power n, isn't it? So it's going to be x bracket 1 plus I to the power n minus 1 divided by I, then 1 plus I. We are dividing 1 plus I to the power n. So when you simplify this one, is going to be PV is equal to, this will go up, so to the power minus n, that is x times 1 plus I to the power n minus 1 times 1 plus I to the power minus n divided by I. So PV is equal to, when you open it, what will happen? This will multiply this term and this will multiply this term. When the first term, what will happen? N minus n going to be 0, isn't it? So x times 1 plus I to the power n minus n minus 1 plus I to the power minus n divided by I, you get it. That is, the final formula is PV is equal to x times 1 plus I to the power n minus n is going to be 0, that is going to be 1, minus 1 plus I to the power minus n divided by I. So this is the formula that we are using to calculate the present value. So I just derived here. You don't need this one. What you need is this formula. It is there in the formula sheet also. Just apply this formula and find the loan amount or monthly installment, quarterly installment, whatever installment, it's like that. So let us do one question, then these things will be very clear. Okay, now look at this question. Sapo takes out a home loan over 20 years to buy a house that cost rent 1.5 million. Calculate the monthly installment if interest is charged at 10.5% per annum compounded monthly. So when you read this question, you know that this is loan is there. So it is about present value. No need of bringing future value formula here. So the two situations are there in your case. One is savings, the other one is loan under annuities. So here loan is there, so present value formula I have to use. So let me write that formula here. That is PV, present value, is equal to installment times 1 minus 1 plus I to the power minus n divided by I. This is the formula. Okay, so you don't need to worry about this formula. How do I memorize this one? You know, it is there in the formula sheet. So only thing that you need to know the situations. Here loan, so present value. If it comes to savings, so future value. So here present value. Now think about what are the items given there. The 20 years, so n is given, percentage is given, and cost, the loan is also given. So what you have to calculate? Monthly installment, that is x you have to calculate. So let's substitute. Present value, I'm going to write 1.5 million, that is 150030. Then is equal to x I have to calculate, then 1 minus bracket 1 plus I is 10%, 10,5, that is 0, divide by 100, 0,105. Since it is monthly, divide by 12 to the power minus, how many years? 20. So change it into months, that is 20 times 12, that is 240. Okay, then close the bracket for the first bracket, then divided by again I, that is 0,105 divided by 12. So I think the learners, they come up to here without any mistakes. The mistakes will come when it comes to the calculation using calculator. So once again I am saying this, should be very careful. So look at here, that is 1.5 million. Okay, so it's equal to x. When you do this one in the calculator, so if your calculation is correct, it will give you, that is 100, comma 1622 742. So this is how, don't round it off here. Therefore, the monthly installment X is equal to 1.5 million divided by this one, that is 100, comma 1622742. So when you do it, you will get the answer rand 14,975, comma 6983. Okay, so when you round it off, the final answer is 14,975, comma 70. This is the final answer. So is it clear? So learners, now you know that this is the grade 12 topic, that is annuities, where two situations are there. One is for savings, other one is for loan. Okay, so I am stopping here. So in my next videos you will see a lot of questions based on these annuities. So wait for that video. Until that time, bye bye.